Hey ChemStars, this is Mrs. Vanderwooy, and I am going over page notes with you, page 14 of your notes, before you have your quiz tomorrow, or excuse me, quiz today. And so we left you with these here. I gave you the Lewis structures, so now it's a matter of just filling out the rest of the chart. And this is going to be like your quiz shortly, okay? So here's NH3. Nitrogen has 3 atoms in 1 lone pair for a total coordination number 4. 1 lone pair. So if I do that right now, it is trigonal pyramidal. And again, you'll be able to use your chart. So what about the hybridization? It's all about the coordination number 4, so it's S1P3. The bonds, are they polar or not? Sure, I'm going to look up on that periodic table, and nitrogen is 3.0, hydrogen is 2.1, and that's equal to 0.9, which you'll be given the range, and that's under the polar. So is this molecule polar? Well, if it's trigonal pyramidal, then it's definitely not symmetrical. How do I know? I have a lone pair. So it is not symmetrical. I have polar bonds, therefore it is a polar molecule. So what kind of intermolecular forces do I have? Every single one of these. Notice they all start off with London dispersion, every single one of them. If it is polar, then there's also dipole-dipole. So there's 2 poles that will attract those 2 molecules together. And last but not least, we talked about hydrogen bonding, and there is a hydrogen attached to a nitrogen, and that makes hydrogen bonding. So again, what is hydrogen bonding? If you have a hydrogen attached to a nitrogen, hydrogen attached to an oxygen as in water, or a hydrogen attached to a fluorine. Those are the only cases where you have hydrogen bonding. So if you're not given an an H bond with an N, an H bond with an O, or an H bond with an F, there is no hydrogen bonding, okay? So here's SO2. My coordination number is 3. I don't know if you can see I have 1 atom, 2 atoms, and 1 lone pair. So it starts off as trigonal planar, but when I have 1 lone pair, it becomes bent. It is not symmetrical. How do I know? I have a lone pair. Oh, my camera froze. So I have a lone pair, so it is not symmetrical. So what about polar bonds? All right, well, oxygen is 3.5. I don't have sulfur memorized. Sulfur is 2.5. So you have 1.0, which, folks, is polar. So once again, not symmetrical and polar. So I do have the 2 requirements for polar, and so I will have London dispersion and dipole-dipole. Do I have hydrogen bonding? Not at all. There's not even a hydrogen on it, so no hydrogen bonding. Finally, SO3, sulfur trioxide. I do have 3 things on it with no lone pairs, so it is trigonal planar. And folks, because it is perfectly symmetrical, how do I know that? 2 reasons. No lone pairs, and everything off of the sulfur is the same element. I have 3 oxygens off the sulfur, making it perfectly symmetrical. What about my bonds? Same as before. 3.5 minus 2.5 is 1.0, so it's polar bonds. Now, wait a minute. Do I have a polar or a non-polar molecule? It is symmetrical. That is not the characteristic of a polar molecule. I have to have a not symmetrical and a polar in order to be a polar molecule. I have a symmetrical, so it is non-polar, and the only thing I have is London dispersions. So that's it. I hope that helps. Good luck on your quiz, and I'll see you on Tuesday. Bye-bye.